Then now we jump right into the first one, which is everything you need to know for inverse functions. So inverse functions, which is your f prime x like that. First thing, in order for f prime x to exist, the condition to exist is that f must be one-to-one function. Okay, now you all know this by heart, right? But do you understand why f needs one-to-one in order for inverse to be? The idea is very simple. Let's say I draw two diagrams over here. Okay? This is diagram 1. This is f is not one-to-one, and then over here, let's say I draw another diagram here, right? It will look something like that, where this is x1, y1, this is x2, y1. So actually, is this still a function or not a function? It is still a function because one input give me one output. One input give me one output. So each input will still give me one output. So it's still a function, but it's not one-to-one because the output, right, is not unique. So this graph, actually, you can think of it like your quadratic, right? If I draw a quadratic curve like that, this is y, this is x. If I draw a quadratic curve, you see that this value of y1, right, has two possible x inputs, x1 and x2. So two different x values give me the same y value. So this is therefore not one-to-one, but it's still a function because if I draw a horizontal line downwards, right, you see that it passes the vertical line test, what we talked about earlier. So that is where we will draw the horizontal line, right? Like let's say I draw a horizontal line like that, y equals to e to the power of x. Then this is this straight line over here, right? See, there's a one-to-one correspondence, x1, y1. You all know the explanation for one-to-one function, how to write since horizontal line, that one, the statement. Okay, I just write here in case we forget it. So since horizontal line, okay, for this portion, for k is bigger than 0, right? So k must be bigger than 0 in order for it to even intersect. So whatever you write here, right, will change for every question, basically. But then since it cuts the graph only once, then therefore f is a one-to-one function. When you zoom out a bit, you all can take the time to copy this out. But I explain why it must be one-to-one function. So if it is not one-to-one, let's say this is f, this is f. But is it possible for me to have one input, give me two outputs? That means I start from here, and then I have two possible outputs. Not possible, right? Because then this one will define, like, it wouldn't be a function anymore. But if it's a one-to-one correspondence, then if I go backwards like that, then I know that, okay, strictly, this one will go back to this one, and this one strictly will go back to this one. That's why only inverse, then you can have, only one-to-one function. You would not know how to go back to what you started off with. Like, you wouldn't know which x to go back to. But this is the understanding as to why it must be one-to-one function. You just swap the x and y positions, right? But the thing I want to talk about in specific is for quadratics. So let's say y equals to x squared minus 2x plus 1. How do I change this to become f inverse? Because if I change this to become y equals to x squared minus 2x plus 1, right? Then how do I make x the subject? One way is you can complete the square. But actually, there's another way, apart from just completing the square. So completing the square is the most usual way, right? You complete the square, you get x minus 1 square plus 1 minus 1. In the end, you just get this. You complete the square, you get this. Then in the end, you get x minus 1 is plus minus root y, and therefore x is 1 plus minus root y, right? So completing the square is one method. But actually, there's another way, which is to use your quadratic formula, actually. So if you want to use your quadratic formula, if you don't like to complete the square, right, it's also possible. All you need to do, right, is you shift the y to the right hand side. So you get x squared minus 2x plus 1 minus y equals to 0. Then, right, from here, you treat this as your a. So a is 1, b is negative 2, and c is 1 minus y. So you treat y as a constant part of your quadratic formula. Then x equals to negative b plus minus root b squared minus 4ac over 2a. Then you just sub everything inside. So you end up with negative 2 plus minus square root negative 2 square minus 4ac over 2a. Like that. Then you simplify, right, you will get back to this. Yeah. So this is for those who don't like to complete the square. Another alternative method when it comes to quadratic formula. So let's say if this is f, okay, x and y, and f brings me from here to here. This circle, do you agree, is the domain of f? Because this is all the x values that f can take in. Then therefore, this will be the range of f, right? So the connection between these two is that the domain of f is the same as the range of f inverse. And the range of f is the same as the domain of f inverse.
So if you're struggling to understand your JC concepts, be if you're in J1 or J2, we all know that H2 math can be very, very difficult, especially when your school goes through the concept very, very quickly. And in the end, you're just forced to learn everything by yourself. But fret not, because what I've done is that I've created an entire resource, a whole library to teach you the H2 math syllabus from scratch. As you can see over here, I've literally filmed a course for every single chapter. So from sequences and series all the way until the end, which is your correlation correlation and regression, right? The last topic in J2. So for all 16 chapters in your H2 Math syllabus, I filmed a course for every single chapter. And for example, if we take a look at sequences and series, what I've done is that I've broken down every single chapter into modular portions again, right? So for the first part over here, under learning objectives and learning materials and resources, what you can do is you can download all of my handwritten notes that I've created for this chapter and also just use it for your own revision. Apart from that, I teach every single chapter from scratch again. So for instance, let's say the definitions of sequences and series, right? This is the first concept. I literally go through in depth over here and teach you the concept from scratch. And not only that, but you will also be able to get hands-on practice with my guided approach through showing you how to tackle the usual type of questions that usually come up for exams, as you can see over here, right? So I go through every single question in depth, go through every single question in detail so that you will know how to tackle these type of questions in the exam situation, right? So I don't just give you the answer, I give you my thought process as well. And I basically do this for every single chapter in the H2 Math syllabus. So if you want to get your hands on this resource, it's super helpful in helping you to really get crystal clear on what it is that you need to learn in your syllabus and what things that you can ignore so that you don't waste time. And if you want more information about this library, be it if you're in J1 or J2 or even a private candidate, this resource will help you in your revision and you can literally self-study the whole subject all by yourself just by referring to this. For more information about this library, I'll set the number on the screen over here and I'll send you more details about the library as well as more information about our premium 24/7 turnaround marking service that we provide for all library subscribers. I look forward to seeing you on WhatsApp over here.